section of the footing that shows 500 millimeters wide, 250 millimeters high, but on the plan view, the length of it shows 28 meters long. The nice thing about the calculator is I can go in and make some conversions here. I can actually, I'm sorry, I can put the numbers in millimeters. So when I say convert 9, all I'm doing is I'm giving the calculator the units. So I'm going to say 28 meters times. Now, I don't want to make the mental conversion of 500 millimeters into meters, so I'm going to put in 500. And I want to give the units of millimeters. So convert 9 will assign millimeters to that number. And then I'd like to multiply that by the 250, again, millimeters, and hit equals. And now I get 3.5 cubic meters. Okay, so sometimes with your calculator, you don't actually have to do that conversion. You can actually type the numbers in millimeters and work through that. But the other nice thing is this. I can put this calculation into the calculator with no problem at all. Okay. I will clear it. Is that the biggest view I have? Hang on one sec. Picture size. Oh, no, that's large. Okay, as good as I can do. Whoops, wrong screen. I'll clear it, and I'll put in 33,000. Now, you can see it's a lot of extra typing. It would be just as easier to put that in as 33 meters if I would have just read it that way. Okay, let's remember it's 3,800 millimeters. Let's set the units on it. Let's multiply that by 10 inches. I don't have to convert 10 inches. I can just type in 10 inches. And then I'm going to multiply that by the 3,800, which is 3.8 meters, but I'll put it in the millimeters and hit enter. I've got an answer in cubic yards. If I want it in meters, I can just put it into meters. Okay. So we can mix units in the calculator. We can mix units. We can mix even formats. We can go in with imperial format and metric format, combine them in a calculation, and it will come back and give you the correct answer. Okay, 31.85. I'm thinking that's what the answer is. 41.66 cubic yards, 31.85 cubic meters. Okay, and again, with your regular calculator, you had to convert your 10 inches into meters. You had to, you had to do a lot more work here. So one of the first things that we're going to talk about when we actually start doing mathematical calculations is perimeters. We like to use perimeters. A perimeter is very handy, especially if I'm looking at a building, because I like to know what the total length around the building is. And it's a number that can be extremely helpful when I'm calculating things like the concrete quantities for the foundation wall, for the footings that go underneath the foundation wall. And they're usually easy measurements. Okay, because the perimeter is a number that I can get off the drawing by doing a little bit of work. Okay, and most drawings will tell me the overall size of a house. If I have a building or a house, usually it's going to tell me the total length and the total width, and I can use those numbers to calculate the perimeter. Knowing that, I know that the length of the footing or the foundation wall or the trench, everything going around the edge of the building is a function of the perimeter. And if I wanted to calculate the real length of it, I would measure that down the center line. What we're going to do is we're going to start off with the very first number, which is easy to get off the drawing, and that's the outside wall surface perimeter. if I have a rectangular building, the outside wall surface is as simple as 2 times the length plus the width. Okay? And we're going to start with that number, and then that's going to give us the ability to modify that number and get some other numbers that are very handy for us. So a rectangular building, 2 times the length plus the width. What does that look like? Well, in this case, it's 49 foot 8 plus 23 foot 6 times 2, and that will give me the length around the outside of that building, that outside line. That'll be the calculated length. Okay. Okay, so determine the OWSP of that building. Oops, let me go back one. All right, 49 foot 8, 23 foot 6. Maybe you guys can run that through your calculator and throw up an answer in the chat here. $146. Well, I didn't get correct, Paul. 146 foot 4 inches. Now, this is giving me a good opportunity to talk to you guys about something. I'll put the correct answer up. We'll ignore the 146 foot 6. We'll look at 146 foot 4. I want to let us understand this right now. 146 foot 4 inches is not 146.4. It's 146 feet and 4 inches. 4 inches expressed as a decimal would be 0.333. So that's the correct answer if I'm using this in decimal format, but in imperial in feet and inches format, 146 foot 4 inches is correct. Okay. Now I can do that on the calculator and save myself some time here by just doing this. 49 feet 8 plus 23 feet 6. Get an answer, multiply it by 2. And if I want to know what that is in decimals, I'll click the feet button and it'll show me the decimals. Okay, but very important, because Denise and I are going to see a lot of your work submitted where you'll just say 146.4, that's 146.4, and that's incorrect. Okay. So let me ask you, if I'm looking at that as the perimeter, let me go back to that. Sorry. So clear that. And if I wanted to also do this as 49 foot 8 as the length and 23 foot 6 as the width, is it equals, Denise, or am I hitting width again? We'll try equals, see what happens. Hit width. Oh, sorry. Okay. So when I click the width button again, it now calculates the area, and now it calculates the perimeter at 146 foot 4 inches. Okay. So let me ask you guys, if that was the perimeter of this building, what's the perimeter of this building? This can't be the same, can it? Paul, you say it's the same perimeter. Sure looks different. In actual fact, it's really quite not different, is it? It is, if I look at the 49 foot 8 inches, I can see I've got 49 foot 8 across the bottom. And across the top here, I have this dimension, 34 feet plus 15 foot 8. They add up to 49 foot 8. If I look at the 23 foot 6 dimension, I can clearly see that here. And now I have the sum of these two numbers add up to give me the same perimeter. So when I'm looking at a building that has what we call a cutout, you're correct. The area is going to change, but the perimeter is not. Okay. There is a situation where that perimeter will change, and it's when I have something like this. And we're going to call this a recess. And that's basically what describes it. It's a recess in the building. Okay, and you can see my 49 foot 8 inches is the sum of all the horizontal dimensions across here, but nowhere have I accounted for this 8 feet. And so when I'm going to do a perimeter calculation for a building that has a recess, I'm going to need to do one more step, and I'm going to take the length plus the width plus the recess, and I'm going to multiply that by 2. If I had more than one recesses in here, I'd add those in here as well, and then I'd multiply the whole sum by 2. Okay? And again, this area is different than the first one, but the perimeter, okay, is very similar, except for I need to add in that extra. Okay? So now if that's the outside wall surface perimeter, that is basically the first number that I can calculate, and I can extrapolate from that number. In other words, if I asked you to calculate the inside wall surface perimeter and told you that the exterior walls here were, let's say, 12 inches thick or 8 inches thick, that'd be harder if I said they're 8 inches thick. You'd be doing a lot of math. You'd have to start saying, well, it's 49 foot 8 to the outside. I need to subtract 8 inches for this wall, 8 inches for this wall. I need to do the same thing with this 23 foot 6, start subtracting. It starts to get messy. But if I did the OWSP first, again, I can extrapolate other numbers from there. So as I said, that inside wall surface perimeter means I have to start going in and calculating those new dimensions. But there's another way of doing it. Okay, that's the long way of doing it. The easier way of doing it is this. Start with the OWSP, the outside wall surface perimeter. Then subtract, and these are constants, 4 times 2. So subtract 8 times. There's going to be a lot of this is going to be contained in your workbook. Okay, you don't need to write it down yet. If I was to do this and say, I could take the existing number that I've got and subtract 4 times 2, 8, times the thickness. Now that would be the thickness of the wall in this case. But what it is this is the thickness. This is the difference between the number that I have and the number that I want. I have the outside wall. I want to know the inside wall, and there's 12 inches between those two. If I wanted to know the wall perimeter, we call that the WP or the wall perimeter, then I'd like to know the dimension of the middle of the wall. And so in that case, I would only subtract 6 inches as my thickness here, rather than the full 12. So now, instead of all that extra calculation, I just take the outside wall surface perimeter minus 4 times 2 times the 1 foot or 12 inch thickness. Whoops, let me go back. And that'll get me to my answer quicker. Okay, and so a lot of what we're going to do is going to be predicated on starting with this OWSP calculation, and then we're going to work off of that number. Saves us a lot of math. So for the previous examples, with that 146 foot 4 inches, I want to calculate the inside wall surface perimeter. I start with that number. I subtract 4 times 2 times 1 foot, and I get 138 foot 4 as my inside wall perimeter. Or in decimals, I would call it this. And the wall perimeter is actually going to be the 1 foot divided by 2, because I don't want the full 1 foot. I actually want to go to the middle of the wall. And so I take half that thickness. Again, 4 times 2 is a constant. It stays there. And that wall has a length. The actual developed length of the wall is 142 feet 4 inches. Okay. So let's do a quick calculation here. Yes, you can do just 0.5. The only thing is, Arlie, I used a simple example of 12 inches, so 0.5 is clear. What if the wall was 8 inches? Or what if the wall was 10 inches? 10 inches, you have to convert that into a decimal. Well, you could start by saying 10 inches is 0.8333 repeated. Divide that in 2, you got 5 inches. 5 inches is 0.41666 repeated, but you don't necessarily have those numbers at the top of your head, like this one. And you're correct, Anthony, it is 8, but I will show you in our workbook why we use 4 times 2. Okay, I'll explain that in a minute. It's fine that you remember 8, but 4 times 2 helps us with this process of understanding what we're doing. Okay, so in this case here, because I know it's 10 inches, I have to remember that it's 0.8333, or I can put that in my calculator. Okay, and again, 114 foot 8 is not 114.8, it's 114.667. Okay. Now, there are situations where I actually don't want to, I may not want to subtract from that number, and I can't plug in yet. I'm going to have to figure another way to plug in my iPad. Oh, hang on a second. Yeah, this is going to be a problem. Okay, just give me a quick second here. Because I do like to, be able to explain this to you in pictures if I can.
Maybe it's a good time to take a 10-minute break.
Oh yeah, we're almost an hour in. Yeah, let's come. When we come back, I'm going to just get my iPad opened up so I can just sort of sketch some of these things out for you. I like to just sort of give you some simple pictures of what we're talking about. So let's take a break. We'll come back at 12:35, and then we'll carry on from there. Okay. Okay, guys, I'm back. And I'm hoping this is going to help to give you more of an explanation of what I'm talking about. Okay, so simple sketch through a foundation of a home, showing the foundation wall. So I've got the foundation wall. The bottom here, I have a footing. And that first number that we calculated was the OWSP, or outside wall surface perimeter. When we subtracted the full thickness of the wall, we got the inside wall surface perimeter. And along the center line of the wall, when we calculate that, we'll get the wall perimeter. And the wall perimeter is, in essence, the effective developed length of the wall. It's the actual length of that wall, okay? So these are numbers that we obtained by starting with our outside wall surface perimeter and then subtracted from there, okay? Because we kept moving in from that number. Now, we can also do the opposite. We can move out from that number. And if I was to say to you, well, I have a trench here, I have to excavate some material around the building, and the trench, it's let's say it's 5 feet wide here and 2 feet wide here, okay? And I wanted to calculate the volume of that. I'd like to know what the perimeter is. I want to know this number right across the middle here. That's probably not a very good representation of that. I'd like to know right at the middle what that is. Well, now I can start to use my outside wall surface perimeter and add to that to get a trench perimeter. Okay, and so what we're doing is we're just starting off with the number that we know we can modify. We know we can work off of the easiest number to calculate, which is the outside wall surface. So we can work in or we can work out to obtain the numbers we need to do our calculations. Okay, and that in that case here, I'm actually looking at the perimeter of the trench. So I'm starting with the outside wall surface perimeter, and then I'm adding to that number because it's going to be a longer perimeter. Okay, so we'll be doing some of that with you. We don't need to get into the details on this one. I'll kind of move past that. But I do want to talk about things like areas. And so the gross area of the building, that's a number that is the total area to the outside wall of the building, outside face of the walls. Well, I just used those two numbers. Remember, we calculated those two numbers to get our outside wall surface perimeter. So we've got a good start here. So for that rectangular building, where we had just done 2 times length plus width, we can now say length times width is going to give me the gross area of the building. Oops, let me go back. I don't want to move too quickly. Okay. I want you to keep that in mind. We're reusing numbers whenever we can. And part of the skill of estimating is finding ways to be effective in how you do calculations. In other words, I have 2 numbers here that I use. I can modify those numbers. I can do all kinds of things. But I'm going to look for numbers that allow me to do multiple calculations. And the overall length and the overall width is one of those numbers. It's very handy for this. Okay. So I can use that to calculate the gross area. I can use that to calculate the outside wall perimeter. And then I can modify or adapt those numbers, prorate them if you would, to get other numbers from there. But I have one nice starting point here. Now, when I have a recess on a building, remember we said that area is definitely going to change. So it's going to be the length times the width minus basically the depth and width of the recess. If I have a recess and a cutout, I'm going to do another calculation, and I'm going to subtract the depth and width of the cutout. Now, that's all good, and that gives me the outside area of the building. But if I'm looking at a building, the inside area is certainly of concern to me, especially in the foundation. If I'm going to pour a basement floor, that basement floor doesn't go to the outside of the wall, it stops at the inside of the wall. It's contained by the wall. So here's a place where I can again reuse numbers that I've already done. I've already calculated the gross area. I've already calculated the wall perimeter. And if you consider the fact that the wall perimeter times the width or the thickness of the wall is actually the area that the wall occupies, then I can subtract it from the gross area, and I'll know the inside wall area, the floor area of the building. Okay, we'll work with these numbers. I just want to sort of get your mind thinking about what types of numbers we're looking for here, and we'll start talking about what we're going to do with our exercises. Okay. Now, what do we do with assignments? Let's go over the rules and regulations of what we're expecting when it comes to doing assignments. Okay. You must hand these in on the assignment worksheets from the workbook and in a folder. Now, if we were on campus, you would actually be giving us a physical folder. But we're going to be doing everything electronic this year. However, there's some standards that have to be adhered to. Okay, whenever you hand in work, it must have the date. If it doesn't have the date, we will get to a point where Denise and I will look at your work and say, no date, no name, 0. We won't mark work that doesn't adhere to at least those minimums. So for the work that we're going to do here, what we're going to do is we're going to have you guys print out and do this work by hand. Okay, we want you to spend some time with pencil and paper or erasable pen if you have it, and we want you to go through this. There's been many studies that have done in education that say that students learn so much more effectively when they're actually writing things down. Okay, that means you actually have to take concepts from your brain, write them out. You learn more effectively. So for the first couple of assignments that we're going to do, we're going to ask you guys to print out the page and then do the work by hand. And when you're finished, you're going to scan it and send it in to us, and we'll mark your work from there. However, when you do that and you make a mistake, that's what an eraser is for. Or if you have erasable ink, you can just erase the erasable ink. You do not scratch out your errors. If you absolutely have to, one single line through the error is enough to tell us that that's not correct. Okay. If you're in industry and you start handing in work to your boss when you're scratching things out like that, it's going to look horrible. So we won't accept it. I want to know how we'll get to that, Jordan. I want to know how you got to your answer. Okay. For you to just put in 3.5, for you to just put in an answer is not helpful to me. I want to know that you understood it. So I want you to do things like write out the formula. Okay. You don't necessarily have to do this, but I want to see the formulas that you've used to get your answers. When you're transferring numbers to Blackboard, let me go back one step with this. When you're transferring numbers to Blackboard, and this is really good training for you guys, because in industry nowadays, many bids are done online. Okay, and it's not just because of COVID, it's been happening for a number of years before COVID. So oftentimes you will have to take your work and submit it in an online format. If you submit the wrong answer in your online format when you did a project, they're not going to care that you actually did it correct, but you just typed the wrong number in. They only care about the number that you typed in. Okay, so we will, when we see your work, you're going to take these answers that you do. When you do it by hand, you're also going to put them into Blackboard. The number that shows up in Blackboard is the number that we will mark you on. If it is wrong, but your work was correct, you have to live with that wrong answer. Okay? Now, there's another side of this that I just want to mention. Sometimes we see students submit all the right answers, and they submit their rough work, and the answers that they calculated were all wrong. Now we have a problem, because now what you're telling me is, I did all the work, here's the proof, I didn't do it correctly, but somehow my answer of 41.3 turned into 86.2 when I typed it into Blackboard. What does that tell me and Denise? That you weren't using your work to submit your answers into Blackboard, you were using someone else's work. When that happens, we are looking at a situation where you're clearly demonstrating to us that you plagiarized it. Okay, so be careful with that.
Dino, can we just address one of the questions about can we use the iPad to do the work on? So he's going to be using the electronic format instead of pencil and paper to complete the rough work.
And I would say yes, you can. You're going to, and we're going to get to it in just a minute, Timothy. But we're going to show you what file you'll use to print out, or you could use this same file on your iPad, and then you can write your work into there as well. Okay. We need to end up with it electronically, but if you write your work on an iPad using the PDF file that we give you, that would be fine as well. So again, we want you to be really careful when you put your numbers into Blackboard. Make sure they're correct. Now, there's a conversion. We talk about two different things here. We talk about soft and hard conversion. In a soft conversion, 10 inches, as we saw with our calculators, is 254 millimeters. A hard conversion is based on this fact, that 1 inch equals 25 millimeters. The soft conversion would be 1 inch equals 25.4 millimeters. Okay? But we will often talk about the hard conversion because in industry, that 1 inch equals 25 is a really handy number to keep in our heads. In other words, if 1 inch equals 25 millimeters, 4 inches equals 100 millimeters. 8 inches equals 200 millimeters. So we often use the hard conversion in industry because it's easy to remember. There are going to be times on our assignments when Denise and I will specify to you, we want you to use a hard conversion. And if you don't follow that instruction and do a soft conversion, the answer will be marked wrong. We know that there's very little difference in the answer. We know that it's technically a correct answer, but when the request was use a hard conversion and you didn't follow that instruction, then even if the number is technically correct, it's still wrong. Okay, so we're going to sort of reinforce this soft versus hard conversion in our class. And again, anytime I'm doing a calculation in metric, I do not want you to give me millimeter calculations. I want to see meter calculations. Feet and inches, those are going to, at some point in time, those feet and inches values are going to have to go into Excel. And putting them into decimals is really good practice for when we're going to start to use Excel. When we do, there will be no allowance for putting in feet and inches. You will have to make the conversions to decimal. So we'd like to see you make those conversions. So here's our work in a nutshell. If you give me the right answer with the right units, you get full marks. That's obvious. If you give me the wrong answer and the right units, I will give you partial marks. Okay, you could have done your math a little bit incorrectly, but you know the correct units. I'm going to give you part marks for that. But if you give me the right answer with the wrong units, think back to that 125 cubic feet as opposed to 125 cubic yards being $600 as opposed to $16,600. You can see why the right number but the wrong units for me is a real big no-no. And so at that point in time, I'm not going to be able to give you a mark for any of your work. Even though you did the right math, when you put the wrong units on it, you negated the correct work that you just did. Okay, and we'll stick to that pretty tight. And some of you are going to be upset by that, but we're establishing the rules right up front, so you know what's going to happen. Okay, so our first assignment is going to be at the end of next Monday's class, meaning you can start it after today and we can spend time working on it in Monday's class. Now, I want to be clear, whenever Denise and I do this, some students are sitting there right now saying, perfect, I don't have to start that until next week. We got 2 hours of class time. No problem, I'll get it done. And especially when we're on campus, we watch those students scramble like crazy in those 2 hours and end up finishing saying, I only got it half done. So we're telling you up front, this is the type of assignment you want to spend some time working on it during the week here, during the weekend. When you come to class on Monday, let's deal with questions that you have. Let's deal with things that you're not sure of. You can put the finishing touches on it, and then you can hand it in. Okay? But if you think that there's enough time in class, there probably isn't, and you end up submitting half-completed assignments because of that. So the lesson on Monday, the time in class is going to be spent not as a lecture, more as an interactive thing where you guys will be doing some of the work, and you may have some of the work to complete it, and we'll help you with that. Okay. So how do we scan our work? Good question. Most of our phones have a function called Office Lens. If you don't have it, it's easy to get. And you guys should be on your phones. You should be downloading at least Microsoft OneDrive. You have an account for it, okay? And Microsoft OneDrive has a feature that looks like this. And when you open up OneDrive on your phone, you'll see this little scanning button on the bottom. That scan button allows you to scan a printout. And so if you have a printout, you can scan it, you can save it, and you can submit it. In fact, you can submit it right into OneDrive. You can save it in OneDrive, then you can submit it in Blackboard. And there are other ways. You're right, Thomas. Adobe Scan, there may be other ways that you guys can scan it. Here's the one stipulation that I want to make, though. If it's a 5-page document, I don't want to receive 5 JPEGs. What I want is one document. So if you've scanned it as 5 different images, it's your responsibility to put them together into one and to make that into a PDF file that we can use. Okay, so we want your submissions to come in PDF format, and it's your responsibility to submit one file. We don't want to see 5. I want you to picture this, guys. There's 79 of you submitting work. Okay, if 79 of you submit 5 assignments, 5 pages each, there's a tremendous amount of work that Denise and I have to do prior to even starting to looking at marking your work. And so we're going to start off on the right foot here.
Excuse me, sir.
Yes.
That assignment is available now, or that will be available later?
We'll show you in a minute. So let's start off on the right foot. It's one submission, one file, and that file is going to be in a PDF format. Okay. So next question is, now, and OneDrive actually has the lens included in it. I'm in your workbook, and I'm looking at Chapter 2, Basic Estimating Math. Okay. It starts off with reiterating some of what we talked about already. It talks about metric and imperial systems. And now I've got a page here with some information that I think is helpful for you. Okay, standard way of expressing these numbers. In imperial units, I can call it 12 foot 3 inches. But if I call it 12.25, I need to specify that's lineal feet. Okay, and if I have thousands, I use a comma. In SI, which is Systems International, which is metric, I would only use a decimal. I would not have feet and inches. So this is not 12-225 meters. It must be in decimals. On the metric side, when you read a drawing, you're going to often see this number with a space here instead of a decimal. Okay, that indicates 12,250 millimeters. But in your brains, you just converted that to 12.25 meters. When I'm expressing units, I can use the square. And I can also type square feet as SF. Square meters, I would have to use the square. And for cubic units, again, this is what I want to see. Okay. The next part of this page is, this is just good information for you guys to have available. Very quickly, if you type in 5 inches into your calculator and convert it to decimals, it's going to give you 0.41667. We'll deal with 3 decimals. So all of our linear dimensions, all of our length dimensions will be 3 decimals long. The reason why is this. 5 inches expressed in metric is 125 millimeters. Okay, this would be a hard conversion. Because I'm going to use 3 decimals, and if I want to put this into meters, it's going to be 0.125 meters. Therefore, I'm going to do the same for imperial dimensions. I'm going to go to 3 decimals for my imperial. This is just a handy little reference chart that you've got here. When you're not sure of a number, if you don't have your calculator handy, you can just refer to this page. Okay. Next page talks about the self-study program, which we've already kind of talked about, so we'll move forward. And now we get to assignment number 1. Assignment number 1 starts on page, what is this page? 28. Okay, and assignment number 1 starts on page 28 and goes to page 36. Okay. And so you see right here, you can see right away that the numbers that I'm giving you are expressed in millimeters, but please do not dare try to give me answers in square millimeters. I don't want to see it. I want you to convert this to meters right away, okay? So I've got a number of different areas, different problems Some of these are very similar to what's in the self-study guide. So that would be a great reference point for you guys to use. And in some cases, I'll do things like this. I'll say all the dimensions are given in meters for questions 7 to 16. So I don't have to give you units from here on in. I'm telling you ahead of time that those are all in meters. Okay. And so when it comes to format, what would we like to see? We would like to see your procedure. We would like to understand your thought process in how you did the calculation. Okay. We would like the accuracy for your answers to be 2 decimal places. Now, how would I convert? And let's just look at this. How would I convert? Do I have a pen here? 15.265. What would that be in 2 decimal places? Correct. 15.27. The last number being 5 or greater means that my answer is 15.27. If my answer was 15.263, then when I round that to 2 decimal places, it would be 15.26. Okay? That's as simple as we get. We're not looking for significant digits and that type of thing. It's simple rounding for us. Now, the solution, this is what we like to see. The question is, calculate the area. We'd like to see you tell us what the formula was so we know you picked the right formula. And now you converted it. Now you went ahead and put in the 12'5" into a number. You did the calculation and you filled in the final answer here. Okay, so that's what we're looking for. And the assignment will be done in 2 ways. So you can spend your time again this week, this weekend working on this thing. And on Monday, we'll open up an assignment on Blackboard. And the assignment on Blackboard will allow you to just type your answers into Blackboard. What's nice about that is that it gives you an answer it gives you a grading when you're finished, so you know how you did. Okay, and it saves, you don't even have to wait for us to come back with the answers for you. So Mohammed and others who are looking at this thing saying, well, I don't have a printer, so how will I print this out? If we go back to our workbook, actually, let me just do one thing here because I have a sort of a master copy of the workbook that has all 3 years in it, and I think I'd like to just be looking at your workbook. 1130, here it is here. Okay, this is your workbook. You have a tab here called Resources. If I double click that tab, I have a thing in here called Estimate Sheet Masters. Let's double click that. And I have a very nice page called Workup Sheet. This is perfect for doing this type of homework. Okay, it gives you the opportunity to put in a project. This is assignment 1. It gives you a chance. You don't need the units, but you can put the date in. You can put your name in. Okay, and you've got just a blank page that you can use. Now there's more pages in here. Not all of them you're going to use yet.
We can also solve it on a blank book paper, right? On text notebook.
No. No, we're not going to be using blank paper. We're going to be using these. We said early on that we're going to get a standard format for doing our work. This is a standard format that we're going to use. So about the fourth page in or so is this page. What's nice about this page is that it's already set up for things like if I was doing a volume calculation, I could be using this page to say 10 feet times 2 feet times 0 foot 6 inches, and there are 2 of them. Well, what's 10 times 2? That's 20. 20 divided by, or times 0.5 is 10. Multiply that by 2 again. So my answer here would be 20, and my units would be cubic feet. Okay, and this could be question number 4. And, you know, I can use this page to do the same type of work. Okay, now conversely, if it could, where am I? Whoops, I'm on the wrong page. Sorry, guys. Conversely, I could be back on page 1 here and say, whoops, sorry. Question number 1, and let's say this was a volume of a footing. And you could say volume equals length times width times height, and that could be the 20 feet by, what did I say, 2 feet by 6 inches. You can do your calculation here and say that that is 10 cubic feet, and there's 2 footings. So here's my 20 cubic feet. Okay, so you could do, you could write out your calculation here. On this page, you can write out your calculation on the other page that I showed you. The other way to do it, and this is completely acceptable here, is for you to just, come on. A little bit slow here, guys. Oh, and the other quick way to navigate this is, instead of doing what I'm doing, scrolling down the page, I can come over here to this middle tab here, the bookmarks, and say I want assignment 1, and here I am. And Denise, you're right. Absolutely. Why not just in this case say area equals pi r squared. The answer is going to be pi times, I have a radius in this case, so 4 squared. And I can do the math, put my answer, and then I need to put my answer here with the correct units. What would be the correct units for this first answer? Calculating an area of a circle with 4-meter radius. The correct units, now meters squared is the correct units for the answer. The correct measuring system is metric, so meters. So meters squared is definitely the correct answer for this first one. And we need to see that. It's got to be here. Okay, so you have some options here. There's a couple of different ways that you can do this work. If you, I mean, I would suggest you start with the workbook here, with the assignment. And if you want to, if you need more pages for doing more calculations, you can do the other ones as well. Correct. You're fine to put meters in here, but we are aware that it's meters. And the main thing I care about is that the final answer has the correct units. That's the important part. Final answer should be 2 decimal places behind the decimal point. Yes, you can do that. Now, let me show you one other thing, and this is a suggestion, because when you submit your work, it would be nice not to have you submit the entire workbook. Organize pages. It's a tool on the right-hand side of the page, but it's also a tool up here in the toolbars. If I click Tools, I will come to Organize Pages. Okay. When I click that, it's going to give me all the pages in the workbook. Now, what I can do now is I can click from this page all the way up to this page, just hold down the shift button and it highlights all those pages. Okay. I get all those pages and I come up here and choose extract. And it's going to ask me a question. Do you want them separated? No, I want them in one file. And do you want to delete them out of the workbook? Absolutely not. When I click extract, it's going to create for me a brand new item that has 16 pages in it. And it is the pages from my workbook. Okay. And now I have a separate file that I can save and call it assignment 1. And that's what I would encourage you to do, because now you've got just the assignment saved as a separate PDF file. And if you have an iPad, you can certainly do what I just did and write your answers in here, or you can now print just this file, do your answers by hand, and then scan them and submit them afterwards. Okay, that is the best way to do this. Anthony, please use a more accurate version of pi other than 3.14. In your calculator, you can just type, or you can use the function for pi, and it's going to give you a correct answer. It isn't a big deal when we're looking at small items like a 3'6" diameter circle, but if we have a situation where we're doing a construction site that's, 15,000 meters across, we have to deal with the change in accuracy there. After you've printed them, Jordan, and done the work, when you scan them, we're going to have a link that will open up on Blackboard. You can submit them through that link. And in our class on Monday, we're also going to type the answers into a Blackboard assignment.
I've opened both links up, if you want to show that.
Sure. So if you guys go over to assignments, there's assignment 1 and assignment 1 submission. Now the submission is where you can attach a file, and that's where you'll attach your scanned file. And assignment 1 is where you're going to actually go in and type your answers in. And when you type the answers in, what that means is this: when the class is over, Denise and I can set the parameters for this, and it'll come back and tell you what your answers, what the correct answer was, and it'll tell you what your mark should be for that. Okay, so you'll know how well you did even before we come back to you with some feedback to say you did this right or you did this wrong. Okay, let's deal with any other questions. We've got about 5 minutes left, 6 minutes left. It's been a pretty full class as well. Monday's class is going to be a little more low-key. Here's what's going to happen on Monday. We're going to come in, and there's going to be some of you who did this work over the weekend, and you have some questions, and you're going to be just anxious to get those questions answered. And so we'll get it going, and we'll start off, and we'll answer those questions for you. There's going to be others who are going to have some of the work to complete, and they're going to be working away at it. And there's going to be some of you on Monday who are going to be just starting the assignment. And we're going to know, because the questions you're going to ask us are going to be questions for like question 1 and question 2. And we're going to know that by the end of 2 hours, you won't have it finished. Even though I've warned you, it's going to happen. So let's be in that first group, the people who have actually done the work ahead of time, are prepared, and just have to clarify some answers. And you know what? If we get an hour in and you've got all your questions answered and you've submitted your work, and you say, I don't need to sit here for another hour, I'm already done, then you're free to go. Okay?
We do have that quiz too. Did you say that? I think you might have, but I might have missed it.
Yeah, I think it's in the announcements. Let's just check.
We'll write the quiz at the start of class, I believe.
Yes. So we will have a quiz in our September 20th class, and you're going to see that again on the weekend in our announcement. But we will have a quiz. So at the very beginning of the class, we'll do the quiz. And then afterwards, we will work on the assignment. And again, if you're one of those students who have completed the assignment, you've put all your answers into Blackboard, and you're finished, we're happy for you to take off early if you want. That's the reward for doing work diligently and upfront. And the quiz is about Chapter 1 in our workbook. So Chapter 1 was everything that we covered prior to this math section. Let me close this. And let me do this. So Chapter 1, the part that the quiz is going to be based on, obviously it's not based on some of our little words of wisdom or our videos, but it will be starting with basically this page 8 here. And all this work that we covered in our PowerPoint, and we covered in class. And it will take us up to page 23. I don't think you can click on the quiz yet. Yes, Thomas, it is an open book, so you have your workbook that you can use as your reference. Make sure that your workbook is saved locally on your laptop or somewhere else other than doing it through Blackboard. Because here's what happens. If you are trying to access your workbook through Blackboard, but you're in the quiz, you may get kicked out of the quiz when you click over to the workbook if you needed to do it from Blackboard. If you've got it saved on your laptop, then you don't have to worry about that. So just another reason to make sure that you've saved it. Yes, the definition of open book means that you are allowed to use the workbook as a reference. You are allowed to use your calculator as a reference. And if you actually have to, and I wouldn't object to you, if you needed an answer on a certain, maybe a mathematical formula, you couldn't remember what it was, if you Googled that math formula, that would be okay too. So we're at 119. Denise, should we let them out a minute early?
It's very generous, Dino. I think we should do it.
All right, guys. Thank you for being here. Thank you for your attention throughout. And we will see you all on Monday. And during the weekend or during the time when you're working on this, if you have questions, send us an email. Remember how to send us an email. We cover both of us in that email, and we can answer your questions for you.